All right, back again. So you have a function that looks like that, and that would not be continuous either. Okay, so continuity. All right, well, time to work some problems. So we'll start with number 2. Find each limit using a calculator. Okay, well, I got a calculator. Okay, so the limit x goes to 1/2, minus 1/2, minus 1/2 of 4x squared minus 1 divided by 2x minus 1. It looks like I'm dividing by 0, but I may not be. So we'll go and we're supposed to do it by using a calculator, so that's what we'll do. And so I'm going to go and use this calculator. 4 times C1 minus 1 divided by 2 times C1 minus 1. And I'm missing a parentheses. Where's my parentheses? Parentheses, parentheses, boom. And we'll go and copy, paste it down there. And what are we doing? We're approaching 1/2, minus 1/2. Okay, so we're gonna go put in a 0, and then we're gonna put minus 0.1, and then minus 0.01. That's dumb. Minus 0.2, minus 0.3, minus 0.4, minus 0.49, minus 0.49999. It looks like I'm approaching 1/2. Minus 0.49999999999. Yeah, I think I'm approaching 1/2. So 1.5. Well, you can't put in minus. Well, it did put in a minus 0.5. Minus 0.5. Boom. So it did it for me, yeah, in this program. So it's basically giving me the answer to the. Well, that's what you do. If you're going to use your calculator, you'd initiate it close to the limit. Get closer to closer. See what you're approaching. Is what you're going to do. All right. Now, number 8, we have to do without using a calculator. So, number 8, limit x approaches minus 1, 3x squared plus 7x plus 1. All right, well, there's nothing funny going on, right? So that's minus 6 plus 3 minus 3. And I didn't use a calculator, I did it in my head. I put a minus 1 in there and got a minus 7, and then I added 1 to it and got a minus 6, and then I squared the minus 1 and got a 3, and 3 minus 6 is minus 3.
Okay.
Are you trying to insinuate that my head is a calculator? Is that what you're trying to do?
Yes, that's exactly what I'm trying to do. Can I use that on a test since it's a calculator?
My head? Well, let's try number 16. See that That everybody liked that one so much. Limit x goes to 4, the square root of 3x minus 3. Well, 12 minus 3 is 9, so that'd be a 3. Square root of 9 is 3. Did I use my calculator that time? So using the calculator means I have to go and do a repetitive thing. I only have to do it once. Okay, we have to go all the way out to 35, I guess. Find the instantaneous velocity. Okay, so we'll look at 26. My position at times t is 5t squared minus 7t plus 8, and I want to find t at 2. 4, 20, 20 minus 14 plus 8. 26? Yeah, probably.
Why is the instantaneous velocity equation so the average velocity simple?
I don't know. I'm not worried about it. Why should you be?
Well,
Number.
if I see that problem, it's going to be a little confusing.
No, I don't think so.
No.
You can do it hard or you can do it easy. You want to see it hard? 28. We want the limit as x goes to 3 of x cubed plus x squared. And I'm supposed to use the formulas 1 through 5. Gee, I'd rather just write down the answer. Alright, but I'm gonna use the formulas 1 through 5. Okay, isn't that good? Alright, so I'm all set. So this is equal to the limit as x goes to 3 of x cubed plus the limit as x goes to 3 of x squared, which is going to be 27 plus 9, which is 36. There, I did it. You happy now? Yeah, I agree. I would have done it that way anyway.
Limit's a calculus equation, right? Or a calculus function.
No. Yeah, maybe in your calculator, but not really, no. All right, we're going to do number 36. And, yeah, I don't want to do 36. That's much too much ink. Number 36. I'll do it anyway. I'm going to do number 36. Limit x goes to 3 of x squared minus 4x plus 5 divided by x squared plus 2x. Alright, so I'm going to go limit x goes to 3 of x squared minus 4, limit x goes to 3 of x plus limit x goes to 3 of 5. Divided by limit x goes to 3 of x squared minus 2 times the limit x goes to 3 of x. Now I would never do this problem this way, but just the book said to do that, so that's what I'm doing. But then I can't solve it if I go up some. Yeah, alright, so let's see, this is going to be 9 minus 12 plus 5 divided by 9 minus 6. Alright. 2 over 3. 2 over 3. All right, now we're skipping section 21.3. And what section 21.3 says, if I have some curve, then the slope of a tangent to that curve is equal to something. The slope is the tangent of the curve. That's what it's saying. All right. And it's saying that the slope. Why can't you make your own calculator work? I have no idea.
Okay, so I put it in there, right? And it says limit and everything, but when you hit enter, it says too few arguments.
Well, that must be true. I read it in the paper, didn't you? So can anybody see that? No? Okay, well, we won't show it to you then.
Maybe if the screen was
I can't see it either, so because there's no light on. I would say, what the heck do you have here anyway? You don't say what x is going to.
Well, I tried to.
So
I tried to hit comma x going to 3.
Yeah, but you don't know what the format is. Without your book, you're going to need your book to tell you how to enter it. Because I don't know how to enter it. I could call my daughter. She probably knows. Anyway, so back to the issue at hand. 21.3 we're not doing. So 21.4 is what we're doing next. Oh, yeah. 21.4. So if I have some curve, so I got some curve.
You can't see anything you're doing.
So
Oh, you still have one.
it's not. Don't blame me. Blame William.
Thanks, Bill.
Yeah, there you go. That's better. So if I have some curve, then the point that's tangent to that curve is going to the line tangent to the curve. The whatever that is, that slope of that line m is the derivative of that curve. This is f of x. Derivative of that curve at the point, in this case a. So the slope of every, if I have some curve, so here's some curve like that, which happens to be a sine function, then the slope at each point as I go up this curve is going to be the derivative of that function. So when I go through 0, what's the slope of the curve as I go through 0? Well, it's going to be 1. What's the slope of the curve as I go through 90 degrees? It's going to be 0. What's the slope of the curve as I go through 180 degrees? It's going to be -1. What's the slope of the curve as I go through 270 degrees? 0. What's the slope of the curve as I go through 360 degrees? What's that curve I just drew? I just drew the cosine curve, didn't I? So if f of x is sine x, then f prime of x is going to be cosine x, which isn't this chapter, which is another chapter, so we're getting a little bit ahead of ourselves. So the derivative has a definition which says the limit as delta x goes to 0 of the change in y over the change in x is going to equal the limit as delta x goes to 0, change in x goes to 0, of f of x plus delta x minus f of x over delta x. And that's going to be our definition of the derivative of a function. The derivative of the function is the slope of that function, the slope of the curve of that function at all the points of the function, but that is the long form thing. And for this particular section, we get to calculate those things, and then we never get to do it again because it's until you get to calculus, because it's pain in the rear end, and we'll know other better ways to doing it by then. Okay, but Newton would have said the exact same thing. Newton would have said the derivative of a function is well, it can't use limit. The change in y with an infinitesimal small change in x, which turns out to be I'm dividing by 0, and no one liked him. That's why he didn't allow his calculus to leave until 50 years after his death, because he knew that it would not meet the approval of the approving communities. Okay, so we look at number 2. Number 2 says y is 2 minus 6x. And we want to find the derivative. Alright, so I want the limit as delta x goes to 0 of y of x plus delta x minus y of x divided by delta x. That's what my equation says. Alright, so I'm going to plug that in. Limit delta x goes to 0, 2 minus 6 x plus delta x minus 2 minus 6x divided by delta x. And I get limit. See how much ink I'm wasting? I could have just written down the answer, and I'm wasting all this ink. So I got a 2 minus 2 is 0. I got a minus 6x plus 6x, that's 0. And I've got a 6 delta x divided by delta x. So I can cross both those guys out, and I get a final answer of 6. Now there's a really easy way to do that, which we get to do in the next section, but right now this is the way we have to do it, because we're not in the next section yet. Oh yeah, I'm doing number 4. Yes, I will. So we're going to move back to the definition. The definition says the derivative is the limit as delta x goes to 0. The function at the point x plus delta x minus f of x divided by delta x. Now what is that trying to tell me? Okay, so there, now I got a function, right? I got some point here, right? So I've got some delta x, some change in x right there, just a little bit. So there's x plus delta x sitting right there. And maybe I ought to go and have a better function. But what I'm going to do is I'm going to take change in y over change in x. What's the change in y? Well, the change in y is going to be the function at x minus the function at delta x plus x. That's the change in y, and then the change in x is delta x. So that's what I'm doing. Yeah, well, that's the derivative. Yeah, that's the definition of the derivative. And now I'm going to do number 4. And so I have y is equal to 4x minus 5. And I'm going to say limit delta x goes to 0 of y at x plus delta x for x plus delta x minus 5 minus 4x minus 5 divided by delta x. Limit delta x goes to 0, and now I've got a 4x, I got a minus 4x, they go away. I got a minus 5, I got a plus 5, they go away. I've got a 4 delta x divided by delta x. I can divide the delta x out of top and bottom. I get a final answer of 4.
Question.
Only one?
Yes.
Okay.
Why do we only do 1, 7, and 27 in the set?
Well, that's very interesting. I'm glad you asked that question. Does anybody else care to have an answer to that question?
Not really.
I didn't think so, because the instructor would probably assign another dozen problems for asking such a question, right?
Well, you're not.
Come on, just to the individual that asked the question.
Yeah, Joel, why do you think that is?
Because we're going to do it a completely different way in the next section.
That's right.
So
On
why
Wednesday, when we get to the next section of the book, we're going to find the way real people take the derivative,
So why do we
and not math majors.
These people.
Because the math department is going to take 3 weeks doing it this way, and we'll assign problems doing it this way. And every single person who's ever passed the Tech Math 3 pre-calculus section of Doug Cordoville has always got an A in Calculus 1, because we don't leave anything out.
Okay.
All right, does that answer the question? So limit delta x goes to something, goes to 0. Okay, anybody here going to be in Calculus 1 sometime in their life? Yeah, everybody except Joel. Okay. Yeah, anytime, Joel. All right, so I've got minus 4 times x plus delta x squared. Then I've got minus 4x squared divided by delta x. All right, so that's my definition. I got limit delta x goes to 0. Okay, so I've got, oh, well, I got to multiply it out. Minus 4 times x squared plus 2x delta x plus delta x squared plus 4x squared divided by delta x. Okay, so now I got minus 4x squared. I got a 4x squared there. They're the only two things that go away. Limit. So I got a perfect record that I am maintaining. 2x
So what you're saying
delta
is I should take
x
calculus to ruin your record.
plus delta x squared. That could be something that could be done. Yes. So this goes away, the squared goes away, that goes away. And now as delta x goes to 0, this guy goes to 0, and I have 2x. And there's a minus sign sitting there, so I'll keep it over here, minus 2x. So the derivative, that ain't right. What's 4 times 2? Okay, so this has to be minus 4, 8. There we go, that's right.
Whoa.
Yeah, pretty close, yeah. All right, number 16. Y 1 over x minus 1. Okay, so I'm going to take the limit. Delta x goes to 0. The function at x plus delta x minus the function at x divided by delta x. Alright, well, I don't know. Looks like I need a common denominator, doesn't it? Okay, so my common denominator would have us limit delta x goes to 0. And I have x minus 1 minus x minus plus delta x minus 1 divided by x plus delta x minus 1 times x minus 1 divided by delta x. limit delta x goes to 0. Okay, so I got an x and I got a minus x. I got a minus 1, I got a plus 1. So I got delta x divided by x squared plus x delta x minus x minus another x minus a delta x plus 1 divided by delta x. Limit delta x goes to 0. These two delta x's can go away, right? 1 over x squared minus 2x plus 1. Delta x's go to 0, so they go away, and I'm done. So, we'll check our work. So if f of x is equal to x minus 1 to the minus 1, then f prime of x is equal to minus x minus 1 to the minus 2, which would be minus 1 divided by x squared minus 2x minus plus 1, which is or is not what I got, which is exactly what I got, but I have a minus sign there. Oh, bummer. Where'd my minus sign go? X minus delta, oh, right there. See that minus sign? Minus, and I got the same answer. So today we have to do all of that to get to there, and then get the wrong answer because we dropped the minus sign. Okay, and Wednesday we get to do that, which is half the work, and get to the same answer and get it right. Isn't that great? Yeah, totally wonderful. Okay, so that was 16. We'll try 20. That works so well. Y is equal to 1 over y squared. Who's the idiot that wrote that? X squared minus 1. Alright, so we're going to look at limit delta x goes to 0, 1 over x plus delta x squared minus 1 minus 1 over x squared minus 1 divided by delta x. Right. I haven't done anything wrong yet, I don't think. Alright, limit. It'd be nice if I changed colors on this pen every now and then. It goes to 0. I need a common denominator. Okay, so x plus delta x. No, that's not that. X squared minus 1 minus x plus delta x squared minus 1 divided by x plus delta x squared minus 1 times x squared minus 1 divided by delta x. Now, we messed up last time. Let's see if we can do the same thing this time. Okay, so limit delta x goes to 0. So I got x squared minus 1 minus x squared minus 2 x delta x minus delta x squared plus 1 divided by, oh gee, I don't know, divided by x squared plus 2x delta x plus delta x squared minus 1 times x squared minus 1. The whole thing divided by delta x. Isn't that lovely? That's just so marvy. Limit delta x goes to 0. Alright, so I've got a x squared, I got a minus x squared. I got a minus 1, I got a plus 1. I've got a delta x, and I got delta x's over there. Alright, so on the top, I have minus 2x minus delta x divided by what I have on the bottom, which is x to the 4th plus 2x cubed delta x plus x squared delta x squared minus x squared minus x squared minus 2x delta x minus delta x squared plus 1. Alright, so I'm assuming that I did that right. I got limit delta x goes to 0 minus 2x minus delta x. Well, we'll just get rid of that for a moment. I think we can do it without it. Now, x goes to 0. Delta x goes to 0 means that this guy goes to 0, that guy goes to 0, that guy goes to 0, this guy goes to 0, that guy goes to 0. And now I can just write down what I have. Minus 2x divided by x to the 4th minus 2x squared plus 1. If I could spell x to the 4th. Alright, so that's what I think my final answer is. And now we're going to go and check our work using the methods from Wednesday that we don't have yet. Alright, so f of x is equal to 1 over x squared minus 1, which is x squared minus 1 to the minus 1. F prime x equals minus 1 x squared minus 1 to the minus 2 times 2x, which is minus 2x divided by x to the 4th minus 2x squared plus 1. Is that what I got? Yes, it is. Check. Huh? Yeah, that's the right one. Now, let's see. If I do number 27, then we can go home, right?
Yeah.
Yeah. Okay. So I'll do number 27 next. Number 27. Y of x is 1 over the square root of x minus 1. Alright, so I got the limit, and delta x goes to 0. 1 over square root of x plus delta x minus 1 minus 1 over the square root of x minus 1 okay, divided by delta x. Okay, well, let's see. I need a common denominator. Alright, so I got limit delta x goes to 0. Now I'm going to have square root of x minus 1 minus the square root of x plus delta x minus 1 divided by the square root of x plus delta x minus 1 times the square root of x minus 1 divided by delta x. Alright. Limit delta x goes to 0. Now it looks like I still have delta x minus 1 on top minus x plus delta x minus 1 there divided by, I'm going to have to multiply these guys out. The square root of x squared plus x delta x minus x minus another x minus delta x plus 1 divided by delta x. Well, isn't that just special? Is that special or what? Now, what in the world am I going to do with that? Be nice if I had a delta x squared someplace I could take the square root of it. Anybody got any bright ideas? Okay. Okay, we're going to multiply the top and bottom by 1 over delta x. 1 over delta x. 1 over delta x. All right. Now I'm going to have limit as delta x goes to 0. Square root of x minus 1 minus square root of x plus the square of delta x minus 1 divided by delta x times the square root of x squared plus x delta x minus 2x minus delta x plus 1. I certainly don't see that helped me any. Now there's two possibilities. One, I've made a mistake and there's no way I can proceed from there and get the right answer. Or two, I haven't had enough Coke Zero today yet to be able to solve the problem. So those are the two possibilities. What's the problem anyway? 1 over the square root of x minus 1. Maybe if we knew the right answer, that would help us solve it. No, we don't need the back of the book to get the right answer.
If you knew the right answer, it would help you solve it.
Yeah, but we don't need that. F of x
That book's long anyway.
is equal to x minus 1
Yeah.
to the minus 1/2. So f prime of x is going to be minus 1/2 x minus 1 to the minus 3/2. So that's what it's going to be. So that'd be minus 1 over 2 the square root of x minus 1 cubed. So that's what the answer is. The issue is, how can I get that from this piece of meat up here, I wonder? Okay, so if we move back to there.
I have a question.
What? Where? Who?
When you did the f prime of x, is that called f prime of x? Not below?
Well, I just call it f prime of x. Yeah.
I know we're doing it later, but
Yeah.
when you do 1 times negative a half, you get a negative a half.
No.
So, no.
Yeah. So we're back to here. Hate to have to start all over. I think that's what I'll do. I'll start all over. 27. So I'm looking at the limit. Delta x goes to 0. 1 over square root of x plus delta x minus 1 minus 1 over the square root of x minus 1 divided by delta x. What I'm going to do is I'm going to multiply this guy by 1 over the square root of x plus 1. One over the square root of x plus 1. Alright, so if I do that, I'm going to have limit delta x goes to 0 of 1 over the square root of x plus delta x minus 1 square root of x plus 1 minus 1 over x the square root of x squared minus 1. That didn't work out very well, did it? Divided by delta x over square root of x plus 1. Yeah, I probably don't want to do that. Better come up with a better plan. Right. Square root of x plus 1. And this guy, we're going to multiply him times top and bottom by the square root of x plus the square root of x plus 1 divided by the square root of x delta x plus 1 minus. That's what we're going to do. Limit x, delta x goes to 0. All right, I got square root of x plus delta x plus minus 1 minus the square root of x minus 1 divided by, okay, over here I'm going to have the square root of x squared minus 1, and that's going to be a plus over there. And over here, I don't know if I want to do this either. No, I don't want to do that either. I'll figure out something to do. Alright, try again. Limit delta x goes to 0. One over x plus delta x minus 1 minus 1 over x minus 1 delta x. I'm going to multiply this by times 1 over x squared delta x minus 1 plus 1 over x minus 1, like that, divided by the same thing. Same thing, S-A-M, same thing. Okay. Now the issue is, can I see both of this at the same time? So I'm going to have, okay, I'm going to do that. So I'm going to have 1 over I'm going to have 1 over x plus delta x plus minus 1 minus 1 over x minus 1 divided by delta x over 1 over the square root of x plus delta x minus 1 plus 1 over the square root of x minus 1. Okay, so that's what I've got. I don't like it, but that's what I got. Now, what am I going to do with that? I can find a common denominator . Okay, I'm going to find a common denominator. Okay, I think I got it. Oh, this is going to be so wonderful if this works. So I got a common denominator of x minus 1 minus x plus delta x minus 1 divided by x plus delta x minus 1 times x minus 1 divided by delta x divided by all this stuff on the bottom. Okay, now on the top I can get rid of the x's, I can get rid of the 1's, I got a delta x, and that delta x can go into there. Okay, so now all I've got on top is a minus 1, right? So all I've got on top is minus 1. I'm going to multiply by this guy, top and bottom, so he goes away, he's going to go into there. Alright, so that's what I'm going to do. So I'm going to have minus 1 on the top divided by x squared plus x delta x minus x minus x minus delta x plus 1 times 1 over the square root of x plus delta x minus 1 plus 1 over x minus 1. And I'm taking the limit. Delta x goes to 0. Okay, now, I'm not dividing by 0 any place, and I can go in and say, in this particular case, this guy is 0, that guy is 0, this guy is 0, that guy is 0, and I can write down minus 1 divided by x squared minus 2x plus 1 times times 1 over the square root of x minus 1 times 2. I hope I did that right. Okay, so now I can flip this around and I can have minus 1 the square root of x minus 1 divided by 2 x minus 1 squared, which is minus 1 over 2 x minus 1 squared, the 2/3, right? Because this is 2 minus a half becomes 2/3, and now I've managed to erase too much. To the 2/3, 3 halves, 3 halves, 3 halves, 3 halves, x minus 1 to the 3 halves, which is exactly what I had before, right? Don't be raising your hand, telling me, you're supposed to be telling me right.
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 Okay, so I believe that at least.
Ooh, right there. There it is.
No idea what the hell is going on.
Right there. There it is. Plain as day. Okay, so the bottom, yeah, that's the derivative.
Right.
Yeah.
But what I'm saying is I think that half the class is unison saying we have no idea what the hell is happening.
So what? What is that? What is that supposed to? Yeah.
Next couple chapters will teach
Yeah, I mean, yeah, exactly. What the whole point is, there's a very difficult way to find the derivative,
That we don't know how to do.
and that you'll have to do during a 3-week period in Calculus 1. And you'll go over and over and over again for that 3-week period. Again, in an advanced calculus class, there's going to be a month section where that's all you do. Okay, and the rest of the time you're going to do what's in section 21.5. So there will be a test question on your Calculus 1 test that says do it this way, and you have to do it this way, and then the rest of the time you're doing it the other way. So this is the way I would do it. 1, 2, 3 steps. I got the answer. But this is 21.4. In 21.4, I have to do that to get the right answer, and I had to do it more than one time because I went on a path that was wrong. See, now if I was a normal calculus type instructor instead of a tech math type guy, I would have my notes with me so I could never take a wrong path. But that wouldn't be any fun. Okay.